Euron. Hello, everybody, and thanks for taking your time to join me today. I think it's fair to say we're all counting seconds for something or someone to beat the COVID-19 pandemic in some way. And today, I'm really excited to tell you the story of a system that I witnessed managed to beat the pandemic in its own way. When we built out the system, we were planning on Christmas and Easter levels of traffic, both of which are large and growing each year. None of us even imagined we were building a system to sustain traffic caused by a pandemic that spurred the run on toilet paper. My name is Sepehr Lorestani, and I'm a mission-critical engineer at Sepehr Phyllis. Sepehr Phyllis is an AWS Advanced Consulting partner with competencies in migration and being well architected. At Sepehr Phyllis, we believe that the right combination of smart people in the right setting with the right intentions can achieve anything. We only have one metric: 100% customer satisfaction for each and every one of our customers. Now, remember that I said I witnessed a system that managed to beat the pandemic in its own way. That system belongs to Jumbo. Let me give you a brief introduction on Jumbo. Jumbo is a supermarket chain in the Netherlands and Belgium. It was established in 1921, and currently it has about 660 supermarkets, 8 food markets, 8 Jumbo City, and a successful online order and delivery service via Jumbo.com. It also has around 60,000 employees and about 22% of market share in Dutch retail market. Now, I need to tell you a bit of history here. Not so long ago, Jumbo had hired an external company to help them roll their online systems out, and they got a pretty complete package from them: website, mobile application, dark store, logistics, you name it. And then Jumbo wanted to bring the whole package online by October 2014. Soon enough, they found out they couldn't get it up and running as they wanted. So in December 2013, they asked Sepehr Phyllis help in order to glue it all together and to make it work. But this was not a simple task. There were a lot of things needed to be changed by the company that sold the software to Jumbo in the first place. And because of time pressure and some political conflicts between the two, the whole process was not so efficient. But anyway, on September 2014, we went live, and we faced a huge load of P1s coming in. But we were lucky that at the time, the number of online orders were not that high, so the damage was not beyond repair. It's 6 years later now, and we are processing a whole new levels of traffic every day. Let me give you an example. As I mentioned earlier, demand for online shopping is growing higher and higher each year. So we had to make sure Jumbo can handle Christmas and Easter traffic. But just about 2 months after Christmas, turned out the same system not only survived, but performed well on the 4 times more traffic caused by the announcement of lockdown in March. Now, how did we do that? Jumbo had its core online services hosted on our on-premise data center here at Sepehr Phyllis. And among those services, the most important one is called Intershop, which is basically the core of Jumbo.com. Our installed version of Intershop was a legacy monolith application developed by another external company with lots and lots of issues, which I will talk about it a bit later. Now, to prepare Jumbo for high traffics, our first mission was to upgrade the Intershop. Why? Because this setup was designed several years ago, and it was good enough for that time. But as you know, how fast the technology is moving and how fast more and more people are using internet in their day-to-day life, simply we needed to upgrade the system and gradually adapt to new levels of traffic. So to do that, we started investigating our limitations. Let me tell you some of those limitations. Imagine the pain of having the whole system spread across 2 data centers ourselves, including an Oracle rack cluster. Imagine the pain of adding more capacity to the system, full machine spin-up, operating system installations, and patches. Imagine the limitations of physical networking gears. Imagine how hard it is to keep a system highly available and fault-tolerant in an on-premise data center. Finally, we decided it was time for the big decision. it was time for us to migrate InnerShop from on-premise data center at Sepehr Phyllis to AWS. Now, the first question is generally, why move to AWS? For many people, this could be a no-brainer, but I think we should touch on the reasons for moving to cloud. At first, Jumbo was hesitant to move to a public cloud, but wanted all the benefits, such as auto-scaling and use of on-demand pricing. Even though their applications were not yet capable of taking advantage of cloud technologies, they knew they wanted them. Jumbo was also looking to take over, or at least practice heavily in their own operations, and they felt this was a better possibility in a public cloud. Also, our team at Sepehr Phyllis highly recommended going to a public cloud solution. We felt this would give us a lot more flexibility in the services we provide, and by being able to resell AWS SaaS services, we would spend more time on interesting projects and less on maintaining services. So AWS was picked. Our team wanted to make the management of AWS environment as simple as possible. At the time, the AWS best practice was one account per environment with the management account to manage them. So we ended up with 5 accounts: development, test, acceptance, production, and the management account to manage them. We also decided early on that Jumbo would start taking apart legacy systems and migrating them into microservices. Kubernetes was the chosen platform. Kubernetes was picked over ECS to avoid vendor lock-in, and since EKS didn't exist in Frankfurt at the time, we had to deploy and manage all of the clusters ourselves. We were lucky kops was available. This greatly simplified the process of deploying and maintaining the clusters. In order to minimize errors, we decided that all configuration changes to the environments should be done via CI/CD pipelines in our GitLab. Let me explain a bit more. For example, the kops pipeline has several stages, including linting, dry run, and deploy. However, deploy is a manual step. Same goes for Terraform. When we make changes, they're committed to a repository that does a Terraform plan. If that looks good, we merge, run a plan again, and then as a manual step, and apply. The nice thing about this is we now are able to use 4 eyes principle and have multiple people reviewing every change. We are not allowed to merge to master our own merge requests. Someone else always looks at the code. As another advantage, it prevents the issue of someone touching the state with a newer version of Terraform and forcing everyone else to upgrade. It also provides a nice and easy audit of all the applies that have been run. In one line, everything AWS related should be done in Terraform via CI/CD pipeline. Having 100% infrastructure as code gave us the benefits of tracking, auditing, and monitoring the changes, tagging resources, and life-saving troubleshooting. Same approach goes for our Kubernetes manifest pipelines. Either if it's Helm or customized, our pipeline runs on every commit, shows us the difference of what we want to deploy and what is actually on the cluster. If it looks good, we merge and manually deploy. Basically, our pipelines detect errors and faulty commits are quickly rolled back. Having this design for our infrastructure gave us more control, less surprises, and lots of good night's sleep. So that covers the basic AWS setup, but the real challenge was getting legacy systems, mainly InnerShop, to work not as cloud native. That was a bridge too far, but as cloud aware, cloud enabled, cloud, I kind of know it exists in some fashion, cloud, I'm not going to panic over 10 minutes because everything is dynamic. But before I share the challenges of this legacy application, let me tell you how important was facing those challenges for Jumbo Supermarket. After the announcement of lockdown by the Prime Minister of Netherlands in March, he did it again, just 2 weeks ago. There was absolutely no way the old legacy InnerShop could survive this sudden increase of traffic. But now, not only it survives, it performs smoothly during this high load. Now let's get back to challenges of our legacy application. As I mentioned earlier, InnerShop is a legacy system. Now, what makes InnerShop legacy? First of all, it expects static IPs and host names. These all need to be hard-coded inside the application. InnerShop also expects to use multicast to share session data among application servers. Multicast at the time was not supported in AWS. Also, there was no method of static asset distribution, such as images, which is pretty crucial part of a web shop, right? On the other hand, the deployment method took a long time, as each machine was upgraded in place and operating system patched by hand. And last, there was a massive amount of data to migrate, but this isn't interesting for this talk because we didn't use any fancy tech. It was just brute force across with multiple rsyncs and dbsyncs. Now, how we faced our challenges. First thing was to use the service discovery. Now, you may ask, why not just use a load balancer in front of the app servers? Well, we thought the same thing, but turned out the InnerShop frontend would only query the load balancer for its first connection. It would then lock in whichever server it was given and talk directly to only that server. If that backend server died, it would not query the load balancer again for a new server. Luckily, there was some support for an old version of Eureka. Eureka is a very basic service discovery application written originally by Netflix. But this problem was not solved yet. Unfortunately, the InnerShop developers decided that each web frontend was capped at 5 servers, because nobody will need more than 5 app servers ever. This did beat us, and after contacting InnerShop support several times, they finally increased the number of servers, and then we overcame our first challenge. Second was the lack of multicast. Luckily, we found out JGroups is supported and could be implemented. So that problem was also solved. Next was the challenge of static asset distribution. So they asked us to spin up more Linux servers with Apache Web Server installed, and told us, make sure you take care of those servers and the synchronization of the images across them. Well, of course, we didn't agree with that, and we came up with the design ourselves, which included S3 buckets and CloudFront. And the last hurdle, InnerShop cannot work in an auto-scaling group. It cannot scale on the fly. By using Eureka to solve service discovery and implementing JGroups to solve session and cache sharing, we are now able to dynamically scale up and down, but in a limited fashion, which was the drawback to our automatic scaling. We learned this with try and error. First time traffic went up, the system scaled up from 6 nodes to 12 nodes. And then we figured out JGroups takes a lot of CPU to run. If we scale out too far, JGroups will spend all CPU cycle chatting with each other and throttle the app servers. And then we reduced the maximum number to 10 and then again to 8. And that was it. We found the optimal point. So as a result, we found out while we're in auto-scaling group, we can only realistically scale at about 10% capacity. However, there are a lot of improvements coming in JGroups, and AWS can also do multicast and transit gateways now. The interesting part is that we have now enabled InnerShop support show up on the site to learn how we managed to do this. When we launched last year, Jumbo was the only customer of InnerShop being able to do this. To sum up, InnerShop was not built for automatic scalability. Now, what we did was tailoring a solution with the help of Eureka, AWS Application Load Balancer, Auto-Scaling Group, S3 buckets, CloudFront, and lots of Chef scripts to overcome this challenge. The most important part was testing at a big scale, simply adding and destroying servers so often that we basically transformed a kind of static web shop into a dynamically scalable web shop. Now, let's talk about deployments a bit. The software had a lot of flaws that we had to compensate many of it by keeping everything super performant in infrastructure level. But as time passed by, we improved day by day. In the beginning, the development model was waterfall, with hundreds of changes in one release. So yes, you're guessing right, we changed that by setting up a software factory and introducing a new way of development to Jumbo. In one line, let's go agile, do small changes, and let's use CI/CD pipelines. Now, let me tell you how fun the deployments were. There were several phases to our deployment evolution. Phase 1. Back in time, the deployments were done by hand. Basically, InnerShop could do only 4 releases per year. We had to do them overnight, starting at around 1 a.m. with an army of people. As you know, such a long development cycle often causes many bugs. They were fated to be disaster. And the worst part, the shop was getting shut down during the deployment. Phase 2, deployments done by a script, again at around 1 a.m. They usually took about 1 hour, and again, shop was getting shut down during the deployment. Phase 3, deployments done by a new script that allowed us to finally deploy without stopping the shop, but still at around 1 a.m. Another improvement was the deployment frequency, which increased to once per week, of course with some emergency hotfixes during the week. Phase 4, the deployment script got integrated into Jenkins, ran still at 1 a.m., and deployment frequency increased to 2 per week, but shop performance would degrade quite badly during the deployment. Phase 5, the golden age, the age of AMIs and auto-scaling groups. 20 minutes deployment at any time of the day, and shop performance will not degrade anymore. Using an auto-scaling group allowed us to modify our deployment strategy. Rather than upgrading existing servers, now we build a system which creates a new AMI for every inner shop version, and therefore we could use rolling deployments. This also has the nice side benefit of us no longer patching machines by hand. Here's how it works. Part of the AMI build applies the latest patch set, and since patches are applied in the build, we know that they're tested with the newest version of InnerShop. And finally, one script scales up the auto-scaling group, adds 2 of the new servers, and then starts killing off the older ones. This also gave us an easy rollback path. Nowadays, we do multiple deploys per day, whilst the shop is running and no one even notices, how it should always be. Now, what saved us? With infrastructure as code, having Terraform managed infrastructure allowed it to be more stable and more predictable, and the one-to-one relation of our code with the actual infrastructure made troubleshooting very easy. On another note, we were able to simplify the networking all around with the help of VPC peering. VPC peering in our management account helped us to allow central tools to seamlessly push to each environment, where before it was routes and firewalls, and in other words, way more complexity. Also, the direct connects enabled other applications that are still in Schuberg Phillips Data Center to have solid communication to AWS-hosted ones. And regarding our Kubernetes cluster, as you know, there are 3 popular options for running Kubernetes cluster on AWS. Manually set up everything on EC2 instances, use kops, or use EKS. As I mentioned, EKS was not available at the time in Frankfurt region. So we had 2 options, and we obviously chose kops. Kops simplifies Kubernetes cluster setup and management. It manages Route 53, auto-scaling groups, ELBs for the API server, security groups, master bootstrapping, node bootstrapping, and rolling updates to the cluster. I cannot even imagine what would happen if we wanted to manage our Kubernetes clusters without kops. On another note, as I mentioned in the deployments topic, auto-scaling groups and AMIs also enabled us to change our deployment strategy. And as a result, we experienced a lot of advantages, such as being able to release more often, immediate feedbacks, faster time to market, less error-prone releases, and much easier to perform deployments. And last but not least, Dynatrace and Datadog enabled us to identify the weak points way faster than before. And as a result, we could prevent disasters way before they happened. And since we're in this topic, I'd like to talk a bit more about our monitoring and security. As Werner Vogel says, everything fails all the time. Now, of course, the key part in this puzzle was our ability to monitor systems. With good monitoring and logging, we could drastically improve root cause analysis and troubleshooting, both proactively and passively. And as a result, it significantly prevented issues and helped us resolve them before they turn into disasters. With the cooperation of the developers, we had been able to leverage Dynatrace and Datadog to give us a view inside of InnerShop and all AWS-hosted applications. The graphs and time boards are good, but the real power was in Datadog anomaly detection. In the early times, we were receiving a P1 every 3 days. But now, with early detection via alarms and automated workarounds, more traffic doesn't have to mean more problems. Platform has even been more stable during the pandemic than the earlier normal days. Worth mentioning, AWS security groups gave us more flexibility and speed than the traditional hardware firewalls we used. Before moving to AWS, it was open a ticket to have a port punched. Now it's just changing the security group configuration. AWS Identity and Access Management and AWS Secrets Manager made our life way easier for maintaining security across the whole platform. Now we can set security boundaries that actually prevents vulnerabilities. On the other hand, WAF and Bot Manager of Akamai also massively helped us to clear up bad traffic on the website. Pandemic traffic was very exceptional. Jumbo had never experienced such a high load on the web shop. However, with proper monitoring and the flexibility that AWS tools gave us, we were able to fine-tune our deploys where and when they were needed. And since we made everything completely auto-scalable before, we were watching the whole story hands-off. The whole web shop scaled to a very high point, totally dynamic. While the existing logistics solutions was claimed to be unbreakable, the pandemic traffic quickly overwhelmed Jumbo's logistics. By keeping the rest of the platform stable and scaling when needed, Jumbo was able to focus on this unique opportunity to load test their logistics and make it actually unbreakable. And this was the story of how the tech beat the 500-pound plague in the room. Thank you for your time. And if you enjoyed this talk, please do not hesitate to get in touch with us via LinkedIn or visit our website.
Thank you, Sepehr. Very nice talk. And well, I'm personally also a consumer and client of Jumbo. And I agree that nowadays it's not the platform anymore from Jumbo.com that's failing, but it's a lack of available slots for your online shopping for the pickup points. So thanks. There are a few minutes left for some questions. So if you have questions, you can post it on the chat channel on the Grip platform, and maybe even after the session, Sepehr will answer there as well. One question: what do you see as the next step for Jumbo and Intershop when it comes to AWS architecture after this? And you may think completely outside the box, obviously.
Yeah, the next basically milestone for us and for Jumbo is to also alter this AWS architecture of accounts that we already have with the new best practices, like using AWS Tower and having one account per development teams, which makes stuff way more interesting. And Intershop is also not just getting upgraded, but at the same time, more and more services are migrating from inside the Intershop to microservices into our Kubernetes platform. For example, during the pandemic, the whole mobile API was on the Kubernetes platform, and our Kubernetes platform scaled from 12 nodes to 34 nodes. So yeah, these are going to be our next objectives.
Okay, thanks. Anything else that you want to end with today? Just 30 seconds.
I just want to say thanks for taking your time, and stay safe, and feel free to reach to me via LinkedIn or visit Schuberg Philips website. Yeah, it's the age of technology, so you know how to find me.